All right. So the topic for today is asynchronous JavaScript. Asynchronous. Everyone knows what asynchronous is. Basically, something that is happening apart from the main loop. So when we are talking about asynchronous, JavaScript itself is a very event driven kind of language, right? You are using it in a browser. So in a browser, what you would do is you would have a lot of interactions with buttons or certain data that is coming from another service, certain APIs and all. So what happens here is you can't wait for these things in order to do certain things. So suppose I am clicking on a button, right? If at the same time some kind of data is coming from external API, then should my button interaction be hampered? Should I not be able to click that button? I should still be able to click that button, right? Because it is very dependent on the user experience. We have to, it was made for a browser. We have to make it very user centric so that all the features work exactly to how the user would experience. So we can't have these kind of blocking operations. We can't have a certain thing that blocks my interaction with the user. Okay, so in that case we use something called as asynchronous programming. So what this does is, rather than having everything on a single piece of code or in a single line, we would offload it to somewhere else, and then whatever happens later on, that happens, right? And sometimes you would have seen, if a website is very slow or something like that, and you click a button, then it does not work. You click 3 4 times, still doesn't work. And as soon as the website becomes responsive again, then all of the button clicks, 3 4 button clicks happen simultaneously. Has anyone experienced that? I think you are on very
Yes,
good
sir.
browsers. Okay, so someone has
Mhm.
experienced it, 2 3 people. Okay, so that is one of the pitfalls of how JavaScript handles asynchronous operations, and we will cover exactly how this works today. Okay, let me start off. Okay, my screen is visible. Okay, so this is what I have created. But before this, let's go on and look at a piece of code with set timeout. Okay, this is visible to everyone.
Yes, sir.
Okay, so you see,
Yes, sir.
we have a console.log at the start. We have set interval in the next line. We have another set interval in the next line. And at the end, we have console.log with a end printing. Inside the set timeout, we are again printing timeout 1 with after 1 second. In the next set timeout, printing timeout 2 with 1 second delay. Guess what will be the output? Any answers? You can directly answer. We don't have a lot of students here, so it's okay. You can directly answer.
Sir, can you show the code?
Yes. This font size is okay, right?
Yes,
Okay,
sir.
this is
So,
even better.
so start and then timeout one and then timeout two.
Yes, exactly. That's the right answer. Start, end, timeout 1, timeout 2. Sorry, start, end, timeout 1, timeout 2.
Mhm.
That is clear because we have a 1 second delay here and here. What if I change this delay to 0 second? What will happen now?
Same, sir.
Same.
Start one, timeout one
Any other
time.
guesses? Okay, so you are right. It'll be the same. But why? Let's see with the help of event loop. That's how JavaScript handles asynchronous code. This is asynchronous because this set timeout is happening elsewhere. It's not happening right now. It will happen later on. This is also asynchronous. Okay, let's see how this will happen exactly. Okay, here we have a kind of structure in which how JavaScript handles asynchronous code. A very specific part of it is what is called an event loop. This is how it handles asynchronous code. Let me explain that in detail. Okay, here we have the code. Is the font okay? I think it's a little bit small, but hard to manage everything here. Can you guys see it?
Yes, sir, it's visible.
Okay, great. Yeah. So here we have, this is the exact same code that we talked about first. So when we are running line by line, so line by line execution will happen, right? So first this line will execute. On the left, it's what is being executed. That's what I'm writing over here. Okay, first line gets executed. What will get printed out? I'm writing the result down here. I'll print out start. Okay, is that clear? First line gets printed out, gets thrown. Now we go to the second line. What will happen here? We have a set timeout with zero delay. Will this execute immediately? This will not execute immediately. It goes to a thing called as a web API. In browsers, we have something called as a web API that handles asynchronous code. So the function, this function inside it, what is it called? It's a callback function. Inside this, there is a function, right? Arrow function over here. This is the arrow function. This is called a callback function because it is sent to another function as a parameter. This callback function will be sent to web API, and then it will tell, okay, execute later on. Okay, now this gets thrown out. Next up, next line goes into JavaScript interpreter. Again, this the function that is being called later will go into the web API. This also keeps track of what the time is. So in here, it says execute after 0 milliseconds. This again execute after 0 milliseconds. Right. So as soon as the 0 millisecond is over, the web API that was keeping track of how much time is remaining sends it to the task queue. This is called a task queue. Task queue is somewhere where all the functions that had to be executed later on will be stored. Okay, and next up, this also immediately it will be sent 0 milliseconds. Simultaneously, the console.log end. This will also go into the interpreter line by line, and the end gets printed out. Okay, start end done gets thrown out. Okay, right now my JavaScript engine, the interpreter itself, does not have anything. The call stack, that means what functions are being called, it's empty. So here the fun begins. So right now the execution thing has been over. The code from top to bottom has been read. That's done. Now the all the which we call the call stack is empty right now. So what we happen what happens here is there is a thing called a event loop over here. Let me write that down. Event loop. So this event loop is very important over here. This is what sends this thing from the task queue, the functions that had to be executed later on, from the task queue back to the main interpreter, the call stack, where we were executing the function. So now, since the event loop is empty, the call stack is empty now, the event loop will check if the call stack is empty, and if it is, then it will send the task, the first task. It says task queue, right? Queue first in, first out. The first task to the call stack. So now this function will run console.log timeout 1. Right? Is this clear? So now next up in the queue, what is this thing? Timeout 2 is next in the queue. Event loop again checks if the call stack is empty or not. And since the call stack is empty right now, it will send the function again to the call stack to get executed. And now this function executes timeout 2. So this is at the end the result that we are getting: start, end, timeout 1, timeout 2. It is all because this asynchronous code has to go through all this. From the call stack, it has to go to the web API. Then from the web API, it has to go to the task queue. And once it's in the task queue, then the event loop checks if the call stack is empty or not. And appropriately, it sends that function, the first function that's there in the task queue, to the call stack. And there it gets executed. Does it make things clear how this thing happens? The asynchronous set timeout? Any doubts? You can ask your questions here.
Sir, but what is that web API thing? Is it
So web
predefined or?
API, yes. So remember, when we are in a browser environment, we have a lot of things that we work with. Right? We have a bunch of functions. So there is whole window object that has a lot of functions, methods in it, set timeout, set interval, console.log. Everything is happening inside this box called as web API. Remember when we were first talking about JavaScript, there is the JavaScript engine that actually executes things line by line, right? And there is a bigger box called as the JavaScript. What do we call it? The whole bigger box that Java, everything that that has everything in it. Anyone? You guys forgot? Okay, so that's called a JavaScript runtime. Runtime has the JavaScript engine in it that executes things line by line. It has the web APIs that allows us to do all sorts of different functionality uh, apart from this thing, the line by line running. So web APIs include the document, the set timeout, set interval, all this function. It also keeps track of how things are happening inside it. So the timer thing that we talked about, 0 seconds, after 0 seconds, web APIs keep track of how much time has passed, and since that time has passed, it will send it to the task queue. So a bigger box inside the whole runtime is called the web API. This is specifically for the browser environment. From the for the Node.js environment, we have a different thing called, I'm not sure what's it's called, but it is similar to this, and it also keeps track of everything. It's the Node.js runtime. Okay, any other doubts?
Yes.
This JavaScript runtime is a bigger box. I think we did something. Okay. So basically, we have a browser, right? We have a browser. So browser has a engine, the V8 engine. And if you're talking about Chrome, we have a JavaScript engine, V8, which executes things as JavaScript intended. We have this bigger box called as runtime, which has this engine plus APIs plus whatever is needed to execute everything. Okay, this bigger box is called the runtime. So with it, we also have this APIs, mm, web APIs that keep track of different things. The document, the fetch API, everything is inside this web APIs. So if you're talking about different things, we have uh, the document, we have fetch API, set timeout, set interval. All this come under web APIs. All right. Any other doubts? Okay.
So basically, what happens is that means whatever we are defining, it goes to our call stack. Then
Mhm.
from there, it goes to Web API. And
Yes.
if there is an async function involved, then it goes to the task queue or callback queue, right?
Yes. So
And,
it will only go to the web APIs if it,
Mhm.
you are right. If it's an asynchronous code, it will be moved to the task queue according to what the condition is. The condition here was if the 1 second, if the 0 seconds passes, then move it to
Mhm.
the task queue, right?
Mhm.
Similarly, we have different kind of conditions. We'll talk about later. We'll talk about promises also. This was a callback based approach.
Okay. So in
Okay.
earlier code, we had this start and timeout one and timeout two. But what if
Yes.
we want to do it like start timeout one, timeout two, and then end?
So the basic thing about this asynchronous code is first all the synchronous things will run only when the synchronous things gets over. Then we go to the asynchronous code. So there are ways in which you can stop the execution. The synchronous code will only run after that asynchronous code is done. We will talk about this exact thing when we are talking about promises. Okay, you will get
Oh,
to understand. So there are certain things that you want to do. So suppose you're getting some data from somewhere, and according to the data, you want to print something. So that printing should happen only after you get the data, right? So you can
so,
actually wait for the data to come and then print something out. So we will talk about this exact thing that you talked about.
so you mean that we have to wait for the data, and meanwhile we can work on something else, and once the data
Yes.
comes, it will automatically fetch us the result based on
Yes.
this
This
asynchronous.
is this was made this way specifically because of user interactions. Because if this timeout one, so right now it's a very simple code, right? But if
Hmm.
this particular line would take probably 5 seconds to execute, then within that 5 seconds nothing, I could not do anything. But in a very interactive, since JavaScript has to be run on a browser, right? So all the clicks, all the interactions that you want to do, that should also happen in that time frame. So it does not block that time. The whole other things could continue while this set timeout is still waiting for it, or a 5 second delay does not matter, right? This happens asynchronously.
Okay.
Got it?
Yes, sir.
Okay. Any other doubts?
So JavaScript is single-threaded, right? And what I
Yes.
understood from the lecture and based on some of my own research is that
Hmm.
once we create a asynchronous context, then this single-threaded loop means how it works in that sense, because JavaScript is single-threaded, and
Yes.
when we use generally asynchronous programming, it creates a separate thread so that we can run on
Hmm.
it, right? So that it runs in
Correct.
parallel, and once the output comes, so JavaScript single-threaded, how it creates multiple threads in that case sense?
Yes, great question. Okay, so everything over here is happening on a single thread. So JavaScript itself is single threaded, but is
Hmm.
your browser single threaded?
No.
Browser can use multiple threads, right? So
Yes.
yes. So the when you're going from all the code that you're running, that happens in a single thread. That's that is why all these things we have to go through. You have to send data to the web APIs, then it comes back, and so on.
Okay.
But if certain things like tracking this, what time it is going on, right? That tracking thing, that can be done on a separate thing, and that is done in a web API that is handled by the browser here.
Okay. So
Got it?
client will handle it.
Yes. So the browser can handle these things, but the whole running of the program that happens in a single thread in JavaScript.
Okay. So it's not means like it is delegating the task. It's actually running it and then
Hmm.
sending it to web API. And if there is a synchronous programming involved, then it will go to the task queue and wait for the data,
Yes.
and then again it goes to the call stack, and it keeps on doing it till the web API, this entire part, event loop and event loop
Yes,
gets cleared, right?
everything is empty. Okay, important thing to note over here is only when the call stack is empty, then only things gets pushed from the event from the task queue to the call stack. Only when it is empty. That means all the synchronous tasks gets completed first, then only asynchronous tasks get executed. That's why even
Okay.
though we have a 0 millisecond on the timeout 1 and timeout 2, still they come later than the start and end.
Okay.
Okay, so let's go one level more complicated. Okay, so I'll let you read this code and guess the output over here. We have a start at the beginning. We have a set timeout. And inside the set timeout, we have another two set timeouts, nested one and nested two. And we have another set timeout outside that. And then we have a console.log end. Okay. So guesses, what would be the answer?
So the start and timeout two, nested one, nested two.
Start end timeout two, then nested one,
Listed,
nested two.
listed to.
Yes, sir.
Is everyone having the same opinion? Any other opinions over here?
So why not like nested one, nested two, and then timeout two?
Okay, start and everyone is clear. That is the first thing. Then you're saying nested one, nested two, then timeout two. Okay. So we have two differing opinions. One is first what it should print this, or first it should print timeout two. Okay, let's go back to where we started the event loop. Let's see how this thing will go into the event loop. That will make everything clear. Delete this. Okay. First things, console.log start gets to the call stack, right? Gets printed. Cool. Done. Over.
Mhm.
Then whole thing, this whole thing goes to the call stack. Since this is the outer function, this will execute, right? This whole thing will go to the call stack. Now tell me what will go to the web API. No, first let's be clear. Are you sure that this whole thing will go to the call stack or not? What is the function that we're executing? See, let's go back here. The function that is executing is this whole thing, right? This whole thing, that is the function that we execute right now.
So,
So
but
the
that's
whole thing,
inside part is function body, right?
but execution happens. Yes, you're right. This is the whole the function body. But when we are talking about execution, then the function will execute. This whole line will execute. So the whole thing will go when we are calling the call stack, inside the call stack. Okay. So now tell me what will go to the web API. Which part? What is the callback function over here?
Set timeout.
I mean, yes. Are these individual lines or the whole function? What will go to the web API?
Individual lines.
Any
So the whole
differing opinions?
function, so the whole function will go,
Yes. The whole function will
and then
go.
it will
Oh,
check for which time interval it has to be executed.
yes. Because when we are, remember, previously what we were doing, this thing, the function, the callback function, this thing went to the call stack. Sorry, the web API. Similarly, now this is the callback function. This is the callback function. So the this whole thing will go to the web API. Understood?
Yes, sir.
Okay. So let me. Okay, so this whole thing, and everything has a 0 millisecond delay. Okay, this whole thing will go to the web API, and immediately, since it's a 0 second delay, zero here, it will immediately go to the task queue. Is it okay?
Okay.
Okay, task queue. Now the second set timeout. This will go here, and this is simple. The inside function will go to the web API. Correct? Here it will go to the web API. This done. Okay. And this also immediately goes back to the task queue. Now this end thing goes here, gets printed. Okay. Now the call stack is empty, right?
Yes.
What was the first thing that's in the task queue? This function. So now this function will execute. See, this function is executing. So this function is executing. Now the new set timeout nested one and nested two, they get moved to the web API. Right. Set timeout is now being created. When the function run, this function run, then only set timeout is created. So now this
So
thing will
this is
go
a
to the.
temporary function, you are saying.
No, it's not a temporary function.
It's
I'm
callback.
saying, so the unless you execute this function, you don't have the set timeout, nested one set timeout. The execution only happens after the see this set timeout. This execution will happen when after the 0 millisecond of the previous set timeout gets over. So only when it comes back from the web API to from the task queue, then only the set timeout will execute.
Okay.
Am I clear? So
So
this
you are
thing will.
taking the entire function,
Hmm.
passing it to web API. Then that
Yes.
entire function, since it has a callback, it goes to the an asynchronous. It goes to the task queue, and now
Yes.
once we get these individuals get back to the call stack, then they get executed. You are saying that?
Yes, exactly. So
Okay.
now, since the this set timeout, this function gets executed, now the callback here, this thing gets moved to the web APIs. So now this thing gets moved to the web API. Okay, this is done. Now, see a similar thing will happen over here. But first, this will be moved here. Okay, since Q, this will be moved here. This will be moved here. And next, nested two, go to the web API. Again, since 0 millisecond, then immediately move to the task queue. Okay. So now my call stack is again empty. What should I do? Task queue, whatever was the first one, goes to the call stack. Right? And now the timeout 2 gets printed out. No, timeout 2. Yes, timeout 2 gets printed out now. Clear? This set timeout done. Now this function, again, call stack is empty. It gets moved here. Nested one gets printed. Function over, done. Oh, okay. Again, call stack empty. Gets moved here. Now this console.log nested2 executes and then prints out. Okay. So
Yes,
this
sir.
is our final output. Is everyone clear with this? Any questions?
So, sir, what I understood from this is that we have to make the inner function like alone, in some sense, if you say, then only it will go to the web API. Say, if I have 8 nested this
Hmm.
callback, right? Then
Hmm.
I have to do it 7 times this entire process, call stack to web
Hmm.
API, then event loop, and finally, once
Yes,
we get the out, means it alone, then we move it to web API, then task queue, and then finally when it goes back, it gets printed
you're right.
or
So if
whatever
I'm
it will.
nesting it 8 times, here if I'm nesting it 8 times, so every time the set timeout executes, it will move the inner thing, whatever is inside it, to the web API. Then the same
Mm-hmm.
process will repeat.
Okay,
And finally, if you're logging out something, then that will be logged out.
understood.
So that means this was the right answer. Or do I have a tick? Right.
Sir, how did we miss to have timeout 1?
Oh, I don't have a timeout 1 over here. I just wrote timeout 2. So this was the timeout 1 that I was talking about, but there was no timeout 1 over here.
In the second timeout, there's no timeout 1. That's why it's not there. Huh?
Yeah. There is no printing of timeout 1 anywhere.
Sir,
If
Hmm.
you
if
want, can we include timeout 1 in the print statement?
Where do you want it?
Just above the
Line
timeout 2, the
here,
last
line
second
number
line
9.
or line number between.
Is it
No,
okay here?
no, even below. Because
Hmm.
of this only, because of the line number 11 only, you are getting timeout only, no? So yeah, we will add that one,
Hmm.
timeout 1 there.
So you want to have a set timeout 1 over here.
Yeah.
Okay.
If you run, what will happen?
What will happen? Any guesses?
Timeout 1 and 2, we will get it.
Timeout 1. So start and end first. Timeout 1, timeout 2, nested 1, nested 2.
Mm.
Okay, let me run it and confirm. Wait just a minute. I will move it to the side. Where is view?
We can also log the timeout one just before the nested one.
Let me first try this out. Okay, I'm reducing one size. It's two. So I'm using Node, but same thing will happen in the browser as well. Node, what is the name? Event loop. Okay, see, start and timeout 1, timeout 2, nested 1, nested 2.
Okay.
Okay. There was one more question.
No, not from
sir,
me. Somewhere else.
I'm asking that here we all have this 0 second as a timeout, right? Suppose if I change one of the timeout to 1 or say 2 seconds, then how the code will change? No, not the outer inner one. Or you
Here.
can do like one outer, one inner. Yes.
Okay, let's change it to, let's keep a significant amount, not 2 seconds, 2 milliseconds, 200 milliseconds. So everything will happen. These are 0 seconds, right?
Hmm.
This will happen immediately, 0 milliseconds.
Hmm.
This will obviously happen at a later point,
Okay.
because as soon as this goes into the web API, then the timer will start. Like,
Hmm.
and then after 200 milliseconds, that is everything gets over, then only nested one will print out.
So you mean the answer would be something like start, end, timeout 1 and timeout 2, then nested 2,
Nested
and
2,
then finally nested 1.
nested one. Yeah.
Okay. And if we change some value, say timeout 2 to 300 or something, so whatever will be set at the maximum, that will come at the last, right?
Yes.
Okay.
So what if we want to start the nested two timeout just after the nested one is finished?
You want to start?
The nested two just after the nested one is finished.
Hmm.
So how will
So
do that?
pretty simple. You have the set timer. This is the function, right? This is the function that you want to start later after the set timeout one has been finished. So you can simply remove it from here and add it over here inside. See, after set timeout one has concluded, so that means uh, okay, after nested one has been printed out, then only nested two will start. Does it make sense?
Yes.
So one doubt.
Yes.
Sir, if like timeout one has value around like say 1000,
Hmm.
then uh, the output will be like start and then two, nested one, nested two, and
Hmm.
then timeout two. So can you run that once?
Okay, so you're on the right track. Start, end. Okay, here you want timeout 2 to be 1000. So 1 second,
Yes, sir.
right? So this will first execute, definitely. This will also go into the web APIs, but it will wait for 1 second in order to go to the task queue. Is that okay? 1 second it will wait. By that time, this also will execute. The nested one, the nested two will also execute. So this will take, nested one will take 200 milliseconds, and after that nested 2 will print, and then finally timeout 2. Start and timeout 1, nested 1, 2, and then timeout 2. Right, makes sense. So if there are different time frames, right, if there's 1000 milliseconds here, 200 milliseconds over here, then it will behave very predictably, because you have already given it what time it is, how much time you want to execute it. Only when you have same time frames, so maybe 1000 here, 1000 here as well, then only confusion arises, right? If I have 1000 here, 1000 here, then only confusion arises. If I have different time frames, then it's pretty simple. It's just the whatever time you have given, the later one will execute later on, because the later one will go into the task queue later. So suppose this goes into the web API, and after only 1 second, then only it goes to the task queue. Okay, any other?
Sir, so basically these time intervals in milliseconds that we're providing determines after how much time it will shift
Hmm.
from the web APIs to the queue, right, sir?
Yes, exactly. So
From the time it went there to.
so this asynchronous code, this is sent to the web API, and the time is calculated inside the web API. So when it is sent is determined by how it is in the call stack. So how we have the function here. So since this function is inside this nested one is inside the outer set timeout, only when the outer set timeout executes, then only this will go into the call stack and then to the web API. So the order that we have decided over here, that determines when it will go to the web API, and the time that we have given determines when from the web API it goes to the tasking.
Sir, I have a doubt regarding stack, sir.
Hmm. Yes.
Sir, we call it in the stack, but it only accepts one event at a time, and
No, no,
unless and
it
until it is empty.
no, it does not have one event at a time. It is the way I have coded. That's why it was accepting one event at a time. What happens? Call stack, one function goes in, and if there is a nested function inside it, that also goes on top. That's why it's a call stack.
You
So
mean
if it's
that if the set timeout goes in the call stack, then this inside set timeout will go means before this set timeout, which is on line number 7. You're saying that?
okay, so
So what
let's
I can't understand is
let's
like
for the call stack, to understand call stack, let's remove the set timeout thing. Let's just think about a normal function. So if I'm having a function function a, right? Inside the function we have another function b, and let me just log out, console.log. It's a, and here I'm console.log, it's b. Okay, we have two nested functions, and let me remove this thing right now. Okay, call stack is a very general concept. Everywhere you will see that in every different language. And let me call this function, let me call a, and inside a I want to call b. So how the call stack will look? First, this will just read. This is just the reading part. This is the function definition. The call stack will be populated only when the execution happens. So like 28. So this thing, suppose it's a call stack. So first of all, function A goes into the call stack. Right, function A executes. And then inside function A, what are we doing? Printing it's A. So it's A gets printed. And then function B gets executed. So now B gets executed. Only when the function B finishes execution, it's B, this gets printed out. Now this gets popped out of the call stack. That's why we call it a stack, because if there are nested functions in it, it will keep on moving up, up, up. If there is another nested function C, then it will have three things in the call stack. It will look like this: A, B, and then when C gets executed, it will be C. And when the execution of C gets over, so here when the execution of C gets over, it gets popped out of the call stack, and now we will go back to function B.
Okay.
And then when B gets over, we will go back to A, and then A gets over. So this is how the call stack works. If there are one function coming at a time, it will only have one function at a time. If there are nested functions, then it will become like a stack.
Okay.
but sir, in set timeout case, when intervals are the same, it behaves like it only takes only one. For the first example, second example, you took it, the whole, so the whole timeout object was, the timeout callback function was shifted from to the web API and then to the
Yes.
queue. So sir, there is no, the concept of stack is vague there.
That's right, but that is because we were only taking one function at a time. So remember a scenario when we had nested one and nested two in a different manner. So instead of nested one over here, we did not have it like this. We had nested one, maybe like okay, 200 here. Set timeout. Let me format it a little better. Okay. So at that time, when this set timeout, this function executed, there were two things in the call stack. These two things were in the call stack. Then
Yes, sir.
only it gets executed. So all depends on how we are making that function calls. the scenario that I chose, that had mostly one function at a time. But in general, if you're using any proper, if you're using even mat 2, you have just started now. Okay, so right now if you're doing this simple things, you would mostly see one or two functions in the call stack. But when you're using certain frameworks or any kind of doing either backend programming, you would see multiple functions being called from different functions and so on. So the call stack becomes very large. You have like 15, 20 different functions being called inside each other. So that happens a lot of time. You will see there's also a thing called as call stack trace. So you would see which function called which function, which called function, and where the error you got. So those things come up here as well. In very simple scenarios, it's not very important. But when you go into actual programming using frameworks and all, the call stack is very important because it becomes very large. You have different functions calling different functions nested in each other and so on. Basically, it all depends on how you have structured the functions. Yes. Any other questions? Okay. I hope everyone is okay with how the event loop works. Just check how, when it is going inside and then how it is coming back. And this event loop, the task queue itself, it's first in first out. It's a queue. So whatever comes in first will go into the call stack first. So from here it will go to the call stack first, whichever came in the task queue first. Okay, shall we move on?
Yes, sir.
So set, so set interval behaves similarly, right? So
Yes, similarly it's just multiple, every inside interval you give a time frame that it repeats whatever is the callback function. This gets inserted in the web APIs every, suppose I'm giving 1 second, every 1 second it will get inserted to the web API. Okay, so next up let's go into promises. So this is called a callback based approach. This is also asynchronous programming, but it is a callback based approach. Why callback? Because we are giving it a callback function to execute it later on. A lot of things are callback based and a lot of things are promise based. Okay, callback, you understand. If I want to make a callback function, so suppose function, just 1 minute. Yes, function. So what I want to do here is, let's take a parameter like a CV. I want to name it something else. Let's name it ABC only. So it takes a parameter called CB, and that CB will be called whenever my function gets executed. So CB is a function. You know, in JavaScript, functions are first class citizen. They can be passed around as parameters. So this is the thing that we use. So do some kind of very time consuming operation and then call the function back. So that's what we call a callback based approach. So suppose I'm running a for loop over here. Okay, and after my operation has done, I will call the function. So how should I call the function? How should I call this ABC function?
One question here.
Yes.
ABC CB is the parameter to that function, right? ABC.
Yes.
and you're calling CB, right?
Yes.
So means like, what are the parameters to this CB then?
Parameter CB itself, when I call the ABC function, the
Hmm.
CB will be a function.
Okay.
Got it? The
CB.
CB will be a function. So I can either give it a arrow function or a manual function, doesn't matter, normal function. So that means this function will be called after the this thing gets executed. After
Okay.
whatever is inside ABC gets executed, I will
Mhm.
call this function. That's why we call it a callback. Call it
Okay,
back
this
later
is
on.
how we define it.
Hmm. So if I want, so let me not give it an arrow function right now. Let's have a normal function that logs something else. Function done. Okay. It's a simple function that just logs out this operation done. So when I'm calling this ABC, I will pass in the function done. Okay. This is a callback function. Now this becomes a higher order function because it is taking another function as a parameter. Okay. There is some noise coming from someone. Please mute your mics. Mohan, noise coming from your mic. Right. Okay. So here we have given this function ABC a parameter, the argument, which is also a function. So we are passing a function as an argument. That thing we can do in JavaScript. That is very flexible way. Since JavaScript functions are first class citizen, we can pass them around like objects. So when this for loop is done, then we call the callback function. Is everyone okay with this? This is one way
Yes,
of
sir.
doing asynchronous code. This is called a callback based approach, and that is what set timeout does. It's a callback based approach. We are giving it a function which will execute later on. I'll just run it and check. Okay, yes. See, 0 to 9 gets printed. Then this operation is done, gets printed out. So this is called
So
a
we
callback based
have done
approach.
that. No? We can do it like this also as well, right? Console.log this operation, then move it to line number 22.
Yes, definitely. This is just a demo that you can do such a thing. So you can do a time consuming operation, and whenever that is done, you call a function that was passed as a parameter to my current function. So that means if
Still, I'm
something
not
was
getting
dependent,
this part. The CB, how you are making it a function then?
I am not making it a function. I am passing a function. See,
Like
Okay,
ABC,
how
this
we are
I
done
making
am
is
sure that
actually
passing
the
a
CB is a
function.
CB.
function.
Yes, I am passing a function.
Okay, okay. So you already know that you will be using it like this. So that's why
Yes,
you are defining a parameter, and once you are done, then you are just calling this done inside the ABC.
correct. Yes.
Okay.
Okay. So this is a very interesting thing that we can do in JavaScript.
So what if CB is not a function?
Then it will give an error. It will say CB is not a function. Suppose I give it x, and x is a let x. It will give me an error. CB is not a function. CB is not a function. Okay. So I have to know that this has to be a function
Mm-hmm.
to do this kind of thing. This is generally done when something is dependent. Right now, the CB is not dependent on the data that is coming back. Suppose CB was dependent on the data that is coming back. So let me have a let data equal to something. So I got data from somewhere and I'm passing that data to CB. This is a more ideal use case because this CB is dependent on data coming from the ABC function. And now if I'm taking some kind of data, I can name it anything. I'll say use okay. Here's the data. So now the done function is dependent on some kind of data that I am getting from the ABC function. Now this makes more sense, does it not? So I'm taking some kind of operation, I'm doing this, and once the operation is done, I get some data back. Or let me not have data here. Let me have, okay, data only. Data equal to, it's an amazing data. So now if I do it, I'll get after zero, after that, I'll get here's the data, amazing data. Okay, understood?
Sir, what if we
Yes, sir.
define let outside the function itself?
This thing outside the function.
Then it will not work, right?
And still it will work because CB will have access to the outside scope as well. So this data I'm getting, it will still work.
Okay.
See, this I'm just giving a kind of demo that how you can have certain function execute after this time consuming function using a callback based approach.
Okay.
So this is one way of doing asynchronous thing. Another way of doing the same thing is called a promise based approach. This is a more modern approach, promise based approach, and that most of the time, not most of the times, a lot of times that we use data in fetch in when we are getting data from external APIs, we use promises and a lot of different things, a lot of different library function that we use will return us promises. If you're using if we are using some kind of file input output, that will also give us promises. So that's a more modern approach of doing things, and this gets rid of this callback based approach. So callback based approach gets very tedious after a while. If there are multiple functions dependent on each other, it gets very, very tedious. So let's look at promises. So promises is a thing, it's an object basically that has three different states. One is pending, rejected, and resolved. Three different states. When a promise is created, the state is pending, and once the promise either gets a proper data back or gets an error. If it gets a proper data back, then the promise status is resolved. And if it does not get a proper data back or gets an error, the status becomes rejected. Okay, that is the whole basics of this promise.
Sir, can you
When we
repeat?
create it, it is pending, and afterwards later then it gets a status of either resolved or rejected. So the basic is, suppose I have I'm getting data from an external API. So when I create that object, that is right now pending, and when I get the data back, it gets resolved. After it gets resolved, then I can continue with all the operations that were dependent on the data that I have gotten from the API. Okay.
So we will wait for the data you're saying, and then based on
Yes.
that, all the methods which are dependent on data, we will run it.
Huh.
But how
And
long?
how long depends, unless I get a resolved or rejected. So it will still be there. So it's a much cleaner way of doing this compared to the callback based approach. Okay, let me first show you how
Sir,
to
we
create a
can say
promise.
that. Sir, can we say that this promises is a way to go around enforcing conditions which are not very easily writable in code, right? We can enforce conditions
Promise
which
is
cannot be written
basically a
in code.
promise that I will do something in the future. That's it.
based on a condition that it gets resolved or rejected, right, sir?
Yes, exactly. Based on the condition. So if it is resolved, I do a certain condition. If it's rejected, I do another set of condition, other set of operations.
Yes, sir, just like if else. But
Yes.
some things we cannot write in if else, so we make a
Huh.
promise.
Not if else, it's more like a asynchronous if else, because this
Yes.
promise would take a little bit of time in order to complete. That's why it's a promise based approach. If it is normal if else, then it will be synchronous. Promise basically is asynchronous because it would take a little bit of time to complete. That's the whole thing. All right.
Yes, sir.
So it's another way of doing the same asynchronous kind of thing, just a different way and a much cleaner way. Okay. So first, let's see how do I manually create a promise. So it's created using the promise constructor. New promise. Okay. You create a new promise using this new promise, and this itself has a takes a callback function. Callback function is another function. Okay, it can either be an arrow function or normal function, doesn't matter. This a and b, these are very important. We call a when promise is resolved. We call b when promise is rejected.
Sir, A and B are names
Okay.
of functions.
A and b are functions, correct. So it seems kind of, the first time I also saw it was like, how can these a and b be functions? Right? But that's how the promise constructor expects it to be. It expects a to be a function, b to be a function, and these are predefined functions. So whenever I call a, it means the promise is fulfilled, so resolved. If I do this, then the promise is resolved, and whatever data I pass here, so hey, we got data successfully. I don't know the fulling spell. Let me correct this successfully. Okay. So if I do this, whatever data I pass in here will be the data for the resolved promise. Okay. Generally, we name it as RES and REJ, but you don't have to name it anything. It can be A, B, X, Y. Doesn't matter what the name is. What matters is what is the position. The first position is for resolve. The second position is for reject. Okay.
So
So
we
this
need
is
not
how
to
we,
specify any if else, right, to check if it's resolved or not. It will automatically
no, this is how to
pass.
create a promise. This is the creation part. To check if a promise is resolved or rejected, we do something else. We have a dot then dot catch.
So sir, here
This
we are
is
basically just defining the this A and B.
yes. We are defining what how to resolve or reject a promise.
I mean, when it is resolved or when it is rejected,
Yes.
what will be the action we're defining it,
Y- yes. The
right, sir?
action we will define later.
But sir, here you have called.
Okay. Right now, this is creation of promise. Right now, after creation, I am resolving the promise. What happens after I resolve the promise? I have to determine it later on. Okay. So this is the promise. This is just the creation part. And let me store it in a variable const prom equal to new promise. Okay. According to this prom variable, whatever is the action. So most of the times I don't know what will be the it will be success or a failure. So I have to write both success condition as fail and the failure condition. I will say prom dot then. That means after the promise gets resolved or reject, then execute this line of code. Prom dot then. The promise that I created dot then. So then itself takes a callback. So after this executes, then we do something. If it gets resolved, then we do console.log. It was resolved.
So
Okay,
this then
promise.
defines the resolved part.
Yes, this is like an if else condition. If it is resolved, then do what? If it's rejected, then do what?
So, but here we have nowhere mentioned if this is a resolved condition or rejected condition.
Hmm. So that's one more important thing. Right now, when I'm using then takes two parameters. So right now I'm given one parameter. Okay, one callback. And if I give another parameter, then this will be for rejection.
So you are using this IIFE function or whatever we call in Python, that lambda function
This
to
is like a
define.
lambda function. It's an arrow function. I
Arrow
can use
function.
It's an
normal
arrow.
function as well. I can use a normal function as well,
Mhm.
but it makes things more verbose. That's why generally inside promises, inside dot then dot catch, you would mostly see arrow functions. So
Okay.
either I can do this or you can do this function. Okay, same thing.
Okay.
So this is one function, this is another function.
So what about B? The function B.
The creation part, right? First, wait. This is we created a promise, new promise, and we resolved it, right? Immediately we resolved it. So it should go into the then's first parameter. So it will log console.log. It was resolved. Okay, first let's see this. There is no other thing, right? Cool. So when I write node promises.js, okay, I get it was resolved. Why? Because when I created this promise, it says I called the function A. If I called a function B, what would happen? If I called function B,
Reject.
yes. So let me not pass any data here. Let me just call the function. It will go into the second parameter, the second callback function of dot then.
Okay.
Okay, it was rejected. So as you can see, depending on what I call inside the promise when I'm creating it, that determines where it will go. If it is a resolution, then it will go in the first parameter. If it is a rejection, then it will go into the second parameter.
That means the function inside the then is passed to the promise.
Yes. And do you think what will happen if I do console.log promise directly? Any guesses?
It will just print out an object.
Let's see.
Object
Even I'm
promise.
not too sure. Okay. It says promise and the status is rejected. Right. Since we created this promise is an object, promise object. And the status, we immediately rejected it. That's why it says rejected. So if I wanted to see the status of pending, any idea what I could do?
Timeout, set timeout.
Okay, so let me add a set timeout here. So inside this, what do I have to do? Suppose I want to reject the promise. I will call B inside set timeout.
Means if it doesn't means concludes or doesn't gets resolved within a certain time limit, then it's rejected, right?
No, if it doesn't get resolved or rejected, then it will still be pending.
Okay.
The time limit we have to set manually. It does not automatically do that. Okay, so in 1 second it will get a value of rejected, but we will log it. This is synchronous, right? Console.log prom. This is synchronous, so it will immediately log the status as promise. So it should be pending. The status should be pending right now. Okay, you see promise pending, and then later on says it was rejected. Okay, so you saw the status pending. You saw the status rejected. So this is what the promise object does according to the status. So first you create a promise. Most of the times you would not be the ones creating the promise. Most of the times we are the ones who are just consuming a promise. So once we done that, we created a promise or something, we got a promise back somewhere. Then according to the status of the promise, we have a dot then first, dot then second parameter. Okay,
So,
getting the flow of it. Yes,
Yes,
go
sir.
ahead.
sir, sorry, I have a doubt.
Hmm.
Uh, Sir, I was asking like if I use like another like something like let promise or where promise.
It doesn't matter. Let 10 see. I have a habit of using const everywhere, but let is the same thing. Const only difference is between let and const. If I say promise equal to something else later on, I can't. So if I have a const here, right? If I have a const later on, I can't say prom equal to something else. I can't say prom equal to 10 afterwards. This is invalid when using const. If I say let, I this is valid. This is valid. That's the only difference between let and const.
Okay, sir.
Are you okay with that?
Yes,
So if
sir.
I'm using let, that is also fine. Generally, I would suggest you to use const wherever possible, since we are not changing the value of prom anywhere. I'm not changing prom equal to something else. I'm not using it in a for loop. That's why I'm using const. Okay, so this is the first part. I have created a promise. According to the status of the promise, I have set what should happen when it resolves, what should happen when it rejects. Clear, everyone? Still
So what,
confused?
so what do we mean by the consumption of promise? How do we consume promise?
This this is the consuming part. This is the creation part. This is how we are consuming the promise. Consuming means what will happen when it's resolved or rejected. How should the code work? Because
Sir, so
accordingly, we should change, right? If I'm not getting the proper data back, I can't print that out. I can't use it in a further function. That's why we have two different ways of consuming the promise. Yes,
so
one more
here
question was there.
yes, sir. Here it will wait for a second to execute the B function, right? To
Yes,
print it was rejected.
yes. Okay. So this is one way I'm using dot then to handle both the cases, rejection as well as resolution. I'm handling both the cases in dot then, but it's not very clean. I can't immediately tell which is for rejection, which is for resolution. So for that case, we emit the second callback. We emit this second callback function, and instead of that, we use a dot catch. This does the same thing as the second callback function of dot then. but it's better. So it does the same thing. We do the same console.log. It was rejected. So right now I can immediately see what will happen when the promise gets resolved, what will happen the promise gets rejected.
It's better in the sense of its structure.
Yes, and you would see this kind of structure more often than not. You would never see in an actual code base, you would never see a second callback of dot then. So it's more like it's more standard practice of having a dot catch than a second callback. But in questions you will get second callbacks, so I have to teach you. Okay, so the dot catch. Okay, so this is for rejection, this is for resolution. Is that
So
okay?
if if we print the whatever is on line number 10, on line number 17 also if you print the same, then it will print rejected, right?
Here,
The object will show rejected.
you tell me. Okay, so we
So
were
because of
talking
this
about
reason,
event loops and asynchronous code. What did I say? Is promise synchronous or asynchronous?
asynchronous.
Asynchronous. What will happen? Uh, when does
Same
asynchronous
thing will
code
happen.
run? After the synchronous one or the later on?
No, sir, after.
Afterwards, right? So this both of them will first. This is like start and end, same thing.
Yes, it
So
is.
this
Okay.
both will say pending, and afterwards, when it goes to the web APIs, go to the task queue, and from the task queue, when it comes back, then only this thing will run. So let me show that.
Sir,
You
how
can
to
see both
identify
says
which one
pending.
is the asynchronous function and which one are the synchronous functions? Like console is asynchronous, right? But at the same time, promise is asynchronous, fetch is asynchronous. How to find that?
Promises are asynchronous by nature. So only when this thing happens, then only so only when the call stack is empty, that's when things from the task queue will be moved to the call stack. So promises are asynchronous. Whenever you see promises, it will happen after the synchronous things. So only asynchronous things are promises and these set timeout, set intervals, these things.
Timing related.
Yeah.
And these promises and everything is like web API. All these part are web API, like
So see,
console.log,
yes,
.10 catch.
same thing happens. So we talked about set timeout going to the web APIs, right?
Hmm.
The same thing happens with the promises also. Goes to the web APIs, goes to the task queue, then gets moved to the call stack. There's a little difference. The set timeout, set interval goes into something called as a macro task queue, and promises go into a micro task queue. That's a little difference. Although you don't have to know the difference, but if you are curious, you can search what is the difference. So micro task queue functions are executed first before the macro task queue, but essentially both are in the task queue. Right. Okay. Is everyone clear to this point? We will go into more complicated promises.
Yes, sir.
Okay. Everyone's clear. So now one more thing. We can also chain multiple dot then dot catches together. So I can have another dot then here. And it doesn't have to be asynchronous. It doesn't need to be a promise here. I can just chain it normally. I can have here console.log. Okay, so this means whenever we are chaining promises, chaining dot thens and dot catches together, what happens is wherever there is no error, it will go into dot thens. So right now, so rejection, you can think of it as an error. It is actually an error only. So think of it as an error. So whenever there is a rejection, it will go into the dot catch. And if it is there is no error, it will go into all the dot thens. So first it will go here, and then it will go here second then. If there is no error here, you can chain multiple thens together. So after this, then, and so on. And you can have a catch as well. But it will go to the catch only when there is an error in between. So let me here have a resolution. So I'm calling A. That means it will resolve first parameter in the promise. That means first this should execute. It will skip the dot catch because there is no error, there is no rejection. Then it will go into the next then.
It's like if and else.
Yeah. So it is like a chain. That's why we called it promise chaining. We have dot then, dot then, dot then. It will keep on going. It says it was resolved and second then. Clear?
So we can set it like after then also, or maybe anywhere, but the then will execute together only. Right?
Yes.
So what's the use of this chaining thens together?
Chaining thens together. So most of the time you would not see it like this. You would have another promise over here. So if I create a new promise over here, it gets interesting once you actually do a lot of things. If I'm creating a new promise over here and returning that new promise,
Fetch API does this, right? In
yes.
general, it returns a promise, and then we need to fetch the JSON output from this, right?
Yes. So if you are returning a new promise, then the because this is again a promise, it has again resolve reject. So depending on this value, the next then will execute. So if you have ever seen a fetch API, so I will just give a demo of how we work with fetch API. If you have ever seen it, those who have not seen it don't need to worry. You have a fetch, you give a URL like google.com, and whatever is the response, I will say then. If it gets a proper response, I get a response object. Okay. And then what we do, if I want it, suppose I'm getting some data from it. So slash API, I'm getting some kind of data.
So JSON
So this
file.
so response object has a lot of different things. It just does not have the data. It has a lot of different things along with the data. So what is the status code? How long did it take? What is the method that I sent? What is not the sent? What are the options API? A lot of different things, like hundreds of different parameters it has. But I just want the data and I want to JSONify it. So what we do is we return response.json. It's a function, it's also a promise. And according to that, we have another then. And then we can console.log. Whatever is this? Okay. I did not write it properly. So data and then console.log. I can have the data. So only after I have received the result, I convert it. This again gives me a promise, and that promise gets resolved in the next then. This is a more ideal, more realistic use case.
Sir, how does res.json makes a promise?
Because internally response is an object, that function itself creates a promise. So the
So
response, this object
the
itself,
JSON function creates a promise.
yes.
Okay.
That rest part creates the promise, and then .json fetches the,
No,
the
no.
data.
Res is an object. Res
Mhm.
has a method called .json
Which
that
creates the
returns the
promise.
promise. Yes,
Mhm.
yes, correct. And
And
see, we are not having, we are returning that promise. Since we are returning that promise, in
mhm.
arrow function, if we don't give brackets, we directly return that. We are
Mhm.
returning that promise, and that promise is caught by the next then. That promise data has been caught by the next then.
Okay, and we are referencing the output as data, right?
Yes. So whatever data, whatever x or y I give over here, that I can get the data.
So here we haven't defined the promises, but we know that it will return a promise, so we have to
Yes.
do it like this.
Yes. And most of the times, you would not define promises. You would use promises. This
Okay.
is what you'll use.
So it will be mentioned in documentation, no? Like
Yes,
it
it
will
is
return.
mentioned that if it's a promise, you either do this or there is another way of using async and await. Okay. I think this makes it much more clear how we can use promises. Okay, so let me clear that. See, now we are chaining dot thens, dot catches. Also, we have a dot finally. We have a dot finally. What does that do? It executes no matter what. It says, I will execute no matter reject or resolve. So it does not matter if it's a reject or resolve, it will execute. Dot finally will execute. That's the that's the benefit of dot finally. So suppose you're interacting with a database, and if the database successfully handles the database, then also you want to close the database. If you want to, if there's an error also, then you want to roll back the database. So that kind of use is for dot finally. So it doesn't matter what happens, this piece of code will execute no matter the rejection or resolution. And you can place it anywhere. This finally can be placed anywhere in between also. Okay. So now tell me what will be the output over here. Let me remove this. We have resolved the promise after 1 second. So what will be the output? Will it go here? Will it go into the first then?
So it will go into the first gen.
It will go. So it was resolved. It gets printed out.
Yes,
Next,
sir.
it will return a new promise. So will it go into the catch block or not?
No, sir. Because the first
It
one
won't.
was already caught.
Okay,
So
it
this is
won't go into
not
the catch block. It will go into the finally block because
And
finally executes no matter what.
in between.
It will go into the then.
Yes,
yes.
sir.
Yes.
Yes.
Since there is no error here, it will go into the then. If there was an error, it will directly go jump to the finally. Okay. So second then finally I will execute no matter reject or resolve. Okay. So let me run it and check.
Sure, in case of error, it would only go to the catch block and then the finally block, right?
Catch block or finally or does it not work like this?
Sir, you are in the PowerShell mode, in the PowerShell editor.
Okay, I think. Okay, never mind. How does and work in PowerShell? Or it does not work? Okay, I mostly use WSL and Linux, so not sure. Okay, so it was resolved. Finally, in between, second then, and I will execute no matter reject or resolve. Clear with this part?
Yes, sir.
Any doubts you can ask?
Okay, so means what I understood from this is that if something is resolved, then it
Mhm.
will always go to the then, and there can be many thens, but they will
Yes,
all run simultaneously, means like one after another. If there
correct.
is an error, it will go to
Hmm.
the catch block, and there can be many catch blocks, which can again run simultaneously. And
No, 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 not exactly. Okay, we'll come
okay,
to that. So once, see, rejection is like a error. Once
hmm,
it goes to the catch block, that error is resolved.
okay,
Okay, after the once you catch it, that means the error is now resolved.
okay,
Now, if there is no error afterwards, it will go to the next now.
okay, and finally will run in any case.
Yes. So accordingly, let me add one more
So
thing.
when it
Maybe
is, when there is an error, it goes to the catch block. But
yes.
who resolves the error in the catch blocks?
Catch itself says okay. That means it's like a try catch, right? If there is an error, then you go. Have you used try catch?
Yeah, long time back, not in the recent past.
Okay. Yes. Like in Python also we have a try except, right?
Yeah, yeah.
So once you go into the except block, that means now the code is okay. It's not an error anymore.
Hmm.
The normal execution will still flow.
Hmm. Yes.
That's what happens. Here also same thing.
Then
If it
how is it
goes into
an
the catch
error?
block,
Then how is it
sorry,
an error? When it
error.
when
So
it
error,
can
there is a way to. This is called a graceful resolution of error. An error occurs, but I'm gracefully um
resolving it.
executing whatever I want. Does not cause an error in the main program. It causes error before that, and I'm gracefully whatever I want to do. If it's an error, I will say okay, it's an error, and the normal execution will continue.
Okay.
Okay,
What
so
type of
next,
error? It's a logical error or syntax error, whatever it
no,
is there.
syntax error will not run. There is kind of what do you say? Lot of errors can be there. Not logical error. Even
So like
syntactical error
database
will work.
errors or network errors.
Yeah, lots of error. Networks error. If there is, should divide by zero will work over here or not. But suppose I'm manually also throwing an error. I expected certain kind of output, but I'm getting a different output. If I want an integer, I'm getting a float. I want to throw an error. So all those kinds of things we can do manually also.
Why don't you give an example here now in this code? Put up an error
Okay.
there.
So let me first do this. So here in line number 13, I changed something. Instead of resolving the new promise that I created here, I'm rejecting the new promise. Now, what difference would happen over here? The first promise still gets resolved. This is still resolved. Prom still gets resolved, but after the prom, the inside the then, I am rejecting the promise, the new promise that I created. Now, what will happen?
The further flow will depend on that promise, the rejected one.
Yes, yes. So will it go here?
Yes.
Yes.
Yes, it will go here. Then
Finally.
And finally,
finally, will it go to the next then?
no, sir.
Mm, remember what I told? Once it goes to the catch block, that means it
It
is
gets resolved, so it will
yes.
go to the new version.
Okay, so then it will go to the normal flow of the program.
Okay.
Okay, sir.
Sorry, sir, could you please repeat, like after finally, where it will go?
To the next then, dot then. I'll tell you why. Let me first.
But sir, for the second then is for the promise created in the first then, right? But that then returns B, which is for rejected.
See, whatever. So if I'm in the catch block, that means my promise, I have gracefully accepted the promise, the rejection. That means the normal flow can now be executed. That's why what we are getting, it was first resolved, this line, because the prom itself was resolved. Here I am having a rejection. So in the catch block, it was rejected. Now, since I have accepted the rejection in the catch, the normal flow will continue. The thens will continue.
But so the first catch is for the promise of prom, right?
No, it doesn't matter. Any promise in the previous chain, wherever. So there can be
So any
multiple
promise
things.
will be caught in the subsequent
Yes, any
catches.
promise before this. Not even promise, any errors basically.
Got it. So any error
Any errors would be
subsequently it will
caught
be
here.
caught.
Hmm. So it was rejected. Then finally, anyways, executes no matter what. Since I had caught the error in this catch block, that's why the next then runs. If I had not caught here, if I had not caught it here, then this will not execute.
Understood.
Understood? Okay, so let me demonstrate that as well. If there is no catch over here, then the only the finally will run. Okay, error happened because this is a rejection, but anyways, it was resolved, this one. Then finally, and I will execute no matter what. And at the end, because that error was not caught anywhere, that's why it gets an error. Okay.
Yes, I
Uh,
got it.
sir,
Hmm.
sir, can you please give an example, like when there is like more than one catch?
Yeah, sure. So in here only I'll add a catch. It's called last catch. Okay. So what happens here, this catch is for anything that happens above it, any errors that happen, any rejection or errors that happen above it, this catch takes that in. And after this catch, and in here, any error happens in these lines, this catch will uh, catch that. This catch will take care of that. Am I clear? Any error that happens after the first catch, this catch already handles all the errors. Anything happens afterwards, after this error and between, before the next catch, then only this catch will take that into account. So right now it does not make any difference. Right now it will not make any difference. Oh, right now it will make a difference. Why? Because
The
it
error
is
will be
having
caught.
an error. Okay, no, it will not have. Suppose
Where we are having error.
no. I previously had commented this, but right now it will catch it.
Yes.
Okay, so what will happen here? It will catch this error. It says it was rejected. Finally gets printed. Second then gets printed. This gets executed. There is no error here after the previous catch. So this catch will not execute. Let me run this. See, this catch did not get executed. Okay. But if there is any error or rejection after the previous catch, then this catch will take care of that. So as I did not check the name, but someone was saying, okay, let me show how do we handle errors? How do we actually create errors, or if there is an error, what will happen? So let me throw a new error. You can throw new errors like this. You can get the value also. Okay, I'm throwing an error over here in the dot. Then see what will happen. This catch takes care of the rejected part. Finally will also get printed, and then this also gets printed because this error is after the console.log second line. Now when I throw this error, finally still gets printed, doesn't matter. Now this catch takes care of the error that was thrown in line number 19. Am I making sense? I threw a new error, line number 19, and this particular catch, the last catch, that takes care of the this error. Okay, so the last catch gets executed.
So means in then
Here
you
we
are
are not
creating
getting
an
any
error.
time.
One after the error, we are creating a error in the then. That's correct.
After that, we will go to the final if block, right?
Yes.
And
If
then
there
to
was a
the
then over here, then that will not execute because
then
there's
it
an
will
error.
not execute. It makes sense. So it is like if else, like based on the conditions we are doing it, right?
Yeah, based on if there's an error, if there's an error, it will go to the catch. If there is no error, it will move all through all the thens.
Okay, okay.
Yeah, one more doubt was there?
Yeah. We didn't give any time interval. So how
No,
does
we
the
did not.
flow be managed?
The flow is directly managed. So it directly goes from one to the other.
Oh, like we start with the no, just scroll up.
Hmm.
Yes, promise here. Then console
Yes.
daughter, it was resolved. Yeah, it was
Resolved.
resolved.
A
So
new
then
promise gets
what
created.
promise is created. It won't go to catch.
It will
Then
go to the catch because it is rejected. I'm calling B over here.
okay, so it's rejected, so it goes to console log. Finally, it goes to finally also, no?
Yes.
Then again console.log second then
Then
because we ourselves are sequencing it so it flow through that way.
yes.
No new error. This is the manual error. Okay. Then console.log. There is no catch here.
The catch is at the end.
Oh, when after the manual error, there is no catch, is it? So
No,
it goes.
not directly there, but at the end. So anything happens between the first catch and this
No.
catch, it will handle anything in between.
Okay.
Because before this, any error happened, this catch will handle, and after that, any error will happen, then last catch will handle.
Okay. It makes sense. Thank you.
Okay.
Sir,
Yes.
sir, if like I also wanted to print like what is written after the new error, that is this is manual error,
Hmm.
can I do that?
Yes, that is very important because whenever you're getting error, you need to print what was the message that error came. So that is taken by the, if I add a parameter over here, E or whatever, don't have to be E. And if I want to print it out, I will just print out E. If I do that and execute it again, you'll see at the last error, this is a manual error. Okay, it also mentions where this error came from. Got it?
Yes, sir.
Yes, sir.
Okay, similarly, remember in A also, this is rejection, right? This is resolution. In A also, we could have passed some kind of data. I could have passed name, my name. Okay, I could have passed some data because generally when we are getting a resolution, we get some kind of data. That data we can get by again adding a parameter over here, some data, or can name it. You can name it anything you want. I'm naming in data, and I can directly console.log that data. So now the name Aditya will come up here. Okay, the data gets printed. Okay, while rejecting and resolving, We can pass in anything. We can pass it as string. We can pass in an object, whatever you want, and that data can be got by the named parameter over here. Am I audible?
Yes, sir.
Okay. I hope this makes sense.
Yes, sir.
Okay. So let's move on to certain different. Most of the things I covered. Only thing is, let's do certain problems. Okay, scrolled. Okay, where is P? Okay, now it should be easy for you to check what will happen over here. So again, we have created a promise P, and we have B, rejected it, and give it a value, a string value of rejected. Okay, so now what will happen? P dot then. Will the dot then run?
No.
Will the second parameter of dot then run?
Yes, sir.
Yes. Okay, so we spend a lot of time on the catch, but the first thing that I explained was the second parameter also acts as a catch. Second callback or second parameter of dot then also acts as a catch.
Hmm.
So this is, since this is rejected, this the second callback will run. And what will it show?
Two.
2. Okay. Now since that has been gracefully exited, the rejection, the dot then, will this run?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay. Dot catch?
No, sir.
No, sir.
No.
No. Dot then?
Yes, sir.
Yes, sir.
Yes.
Yes,
Okay.
sir.
So we get a 4, and then we are throwing an error.
But
Throwing an error,
finally we'll run.
finally will run, and at the end we'll get a error also because we threw an error and
It's
there
not
was
called.
nothing to catch it. Okay.
Okay.
So at the end I'm having one, then, oh sorry, not one, two,
Two.
5, 4, and finally then error. Let's check if our
Sir, this fail is the catch part you are saying.
yes. So previously we were taking just one parameter, one callback
Mm-hmm.
function of then, and we can also take two callback functions. So this is one callback function, there's a comma there, there's another
Mm-hmm.
callback function. So whenever
Okay,
we have
okay.
two callback functions in dot, then the second one acts as a uh, the
Ha, yes,
catch
you
block.
told that. Yes, yes.
Okay. Okay, so I think we were right. 2, 5, 4 finally, and getting an error.
Means whenever we define an error manually, we have to catch it. It's mandatory.
If we
Else we
don't
will
catch
get
it, the
this error.
code will stop at that point.
Okay, okay.
So after this, if I do any console.logs, that will not be visible because the code will stop at that point. Okay. So next up, what happens if I resolve it? Same thing, I resolve it. P dot then success. This will run. One will print. Then second will not run, of course. One will print. 5 will print. 4 will print. And finally, same thing will happen. Only 2 will not print. So 1, 5, 4, and finally, right? I think makes sense now how this works.
Yes, sir.
Yes, sir.
Okay. Okay. Now we have okay a long code. Let me move it on the top. Okay, first let's see what is happening over here. We have a we created this prom again with a new promise. Right now we named it resolve and reject. And inside that, we are creating another function ABC that takes x as an input parameter. So we are saying if x is greater than 20, then we call the resolve function. Okay, this is very complicated. Let's not make it this complicated right now. We just say x greater than 20. Okay. If x is greater than 20, we resolve it, else we reject it. And at the end, I'm giving x ABC value of 22. So what will happen? Resolve or reject?
Resolve.
Resolve. Great. X is greater than 20, so it will resolve. Now I'm having this prom dot multiple things. Let's go line by line, see what will happen. Prom dot then it takes x and returns 40. Will it print anything?
No.
No. It just returns something. And then catch. It will not execute catch because
Will not
resolve.
execute. Hmm.
Finally,
It will execute.
it will execute. But a new problem is there. Where is this I coming from? Any idea what will be the value of I?
From the then
So that
40, 40.
input we have given.
Okay, this is like a curveball. It's like to confuse you. Finally does not take any parameters. If I give a parameter to finally, doesn't matter what happens. It always has a value of undefined. So
Okay.
I will be undefined only for finally. Only for finally.
Hmm.
For then, x is the returned value from the previous thing. Right. Return value from promise was here. What was this thing? Okay, this was the return value. So x was whatever was returned. Similarly for catch, whatever is the error or whatever is the rejection, that is the value here. But finally does not take any parameter. For finally, it is undefined. The parameter. That is just to confuse you. Okay. So
Okay.
next then takes in x as a parameter. Okay, now important thing. What will be this x?
22.
So
22.
x
How
is greater
22?
than
Yeah. What was second option that you said?
x is greater than 20.
Okay. So see, when I'm using dot then dot catch, whatever is the returned value for the previous chain. So in this dot, then what is the return value of previous?
40.
This
40.
is being returned. Okay.
Okay.
For finally, we don't consider finally at all. Finally, just the return value. There is no return value. Doesn't matter what the return value is. Doesn't matter what the parameter is. Just skip this. It's like it will just
Okay.
get printed out. Return value does not mean anything. What was the previous thing in the chain? If I'm skipping finally, it is this then.
40.
Yes. So the return value from the previous thing in the chain is 40. That's why right now the value will be 40 for the parameter that I'm taking. So I will console.log second then and then 40. Now again I'm returning 30 next. Finally will execute no matter what. This will always print. And for the next then, what is Z?
30.
30.
30.
Because in the previous chain I was using 30 as a return value. So third then x into x, 30 into 30, whatever is 900, I don't know. maybe 900, 9,000. Okay, so
900.
So
then
900.
dot, so dot catch, this will not execute.
So if we can use return value twice, like if I write then twice and use the same value like 40,
Return value twice. Can you give me the code for that?
like if I have written then in
Two times.
yeah second then, and if I
Hmm.
write again it after that, will
Here
that
you
be?
are writing dot then again.
Yes, sir.
So it will be the same thing, dot then. And are you taking parameter over here?
Yeah, yeah,
Okay, let me take a y and
yeah. But the previous then is not returning something. Will it use
previous then.
the? Yeah,
Hmm. So console.log, let me log in y itself. So the previous then here is returning 30. So y for it, it will be 30. And
but if
here
we
you don't
don't,
want to return.
yeah,
Here you don't want to return anything.
no, no,
Okay.
the previous then where we are
This
returning
you
30.
want don't want to return anything.
Yes, sir.
Okay. So if I'm not returning anything, what will happen? Does anyone know if I'm not returning anything, what
So
is the return value?
undefined.
It is undefined. Undefined. So
That
y will
means
be
the
undefined.
value is consumed. That
Console.log.
means.
Yes. And for the z also now, because in line number 75 also we did not return anything. I mean, we returned console.log, but that also is basically returning undefined. So that is z is also now undefined. So z into z, what will that undefined into undefined?
So sir, this console.log, that is actually for printing, right? It is not for returning.
Yeah, it is not for returning, but when we give an arrow function and don't give brackets, it returns this thing also, like whatever
Okay,
is the return value for console.log.
okay,
And the return value for console.log is undefined.
okay.
And in here, but in here we did not return anything. We actually did not return anything because we
Mhm.
have brackets. And if we have brackets, then we have to manually write the return statement.
Okay, sir.
Remember, if we don't have brackets, whatever I write arrow, whatever this is the return value.
Mhm.
Okay, same thing. Okay, now tell me what will happen.
What what if we don't print?
Undefined, undefined here finally.
Yes,
And
sir.
here z also undefined. And what will happen here? Z into z.
So error.
Unde- Undefined.
So,
I
NaN, I think.
Okay, so what happens here? Fine. What? Oh, I did not save it. Just a minute. Ah, what were you saying? What will be the answer? Okay, let me go back. Okay, your mind's blown or not? It's not error,
It's a not a number.
not a number. Okay, so these are some things that are weird in JavaScript. Don't have to memorize everything. It just
Sir, you are not audible.
hello. Yeah, sorry, got disconnected. What was the last thing that we were discussing? Hello, am I audible now?
Yes, sir.
Okay.
Yes, sir.
What was the last thing that we were discussing? Did we discuss? I mean, I was saying something and it got
So
disconnected.
the NA,
So NAN, I was saying I will not ask NAN. Okay. So basically, I was going through what will happen. So here, this line is not printing anything. It is just returning the value. Catch will not print because it's a resolution. And finally, this will print. But remember what I said? Finally, it does not take any parameters, does not return anything. So the I is always undefined. Generally, we don't take anything over here in the parameter, but if we take, it is undefined. For the next, then X itself is the one that is returned from the previous chain. Previous chain, we have return 40. So second then X, that is second then and 40. Clear? Next up,
yes, sir.
taken Y, console.log Y. But Y, the previous then, what did it return? It did not return anything. So this Y again is undefined. Again, finally, simply gets printed out. Z. Again, no return statement from the previous dot then. So it gets undefined into undefined. That is NaN. Third then undefined. And then catch will not execute. So I hope this is clear. Taking parameters also and how the chain works. Everyone okay with this?
Yes, sir.
Okay. So last thing that we have to cover, pretty simple. No such fancy things. Why don't we do the same thing instead of doing all this dot 10 dot catches? Feels a bit complicated, right? Why don't we write it like a synchronous code? We can do that. That's that was introduced in a much recent JavaScript update. I think async await. I think it was introduced in 2015 or something like that. Okay. So that was dot then dot catch. This is async await. Concept is same. There's a promise. The promise is either resolved or rejected. Depending on what the resolve or rejected does, we have to execute another set of code. That's the whole promise. But to execute it in a more synchronous kind of looking manner, although internally it does the same thing, but in a more synchronous kind of manner, what we can do, promise creation will be the same, promises are the same, only difference is how we execute that promise, how we resolve or reject that promise. So firstly, we use the await keyword. Await keyword means, this means wait for promise to resolve and give me the result. That's what the await keyword does. Okay, so here it will wait for that promise to resolve and give you the result. But to use this await keyword, I have to create a function. You can't use it anywhere. You have to have it inside a function, and that function has to be an async function. So to define an async function, I use the async keyword. Async function gets some data. Okay. So remember, important thing, this await, anywhere you are using the await keyword, you have to define a async function. And you would say same thing. This prom I will say await prom. Await prom. So await prom means it will wait for prom, either rejection or resolved, and it will store the data. So I will say const data equal to await prom. Does it seem simpler? I will wait for prom this promise to be resolved, and when it is resolved, it will get the data. If it gets rejected, it will directly throw an error. If rejected, okay. And now I can do with whatever I want with data. So I will console.log the data that I got. So what this allows me to do, it feels like a more synchronous kind of code. I can, instead of chaining dot thens dot catch together, I can chain awaits together. I can have await prom, then await data, and so on. And each time I use await keyword, it will wait for that promise to get over, and then it will execute the next line of code. So here I'm having a promise, and I'm what have I done? I have resolved it. X is greater than 20. So x is greater than 20 is the data that I'm getting from the resolve, and this data will be stored in this const data that I defined. Okay, so let me run this code, get some data, and let's see what happens. Other things I commented, hopefully. Yes, I did. And see, I got the x is greater than 20, the data that I got from the resolve. But this is just half of it. It is taking care of dot then, it is not taking care of dot catch. If I want to have a dot catch also functionality, I would have use something like this try, and inside the try I will add the data and I will use catch. And then again catch also same, like we were handling the error. Take actually forgot how to get data. Okay, so I will console.log whatever got an error. Okay, so this is the whole functionality of dot then dot catch, and I can await from a new promise if I want to have a new promise const new from equal to await from to something like that. Whatever I want, I can change multiple. Since prompt2 is not here, I don't need it. But this kind of structure we can have. If I now run it, so since I don't have an error here, I will not run catch anyways. But if I reject it, to reject it, I will have it 19 over here, and this will reject, so it should go into the got error catch block. Uh-huh. Did anyone raise their hands?
No, sir.
Now I got a got error. So this is equivalent to doing prom dot then, and then whatever data I have, and then I'll console.log data and dot catch. Console.log got error. Okay, these two things are equivalent, and you decide what you want to use, this piece of code or this thing. These both are equivalent. So some people like to use this because it reads much more easily than dot catch, you can see. But sometimes people use this also. So both you have to be familiar with. Any questions on this? Async and await is
The
pretty simple.
second code, this prom dot then data. This is the one that we used earlier, right?
Yes. Both are equivalent.
And in general, if I want to, it's like work on things, which will be production grade. So which method should I use? Like, should I use this
Both
await
are
and
so both are okay. Generally, what I do is if there is a simple promise, then I use a dot. Then, if I have to chain multiple promises together, I generally do this because after chaining two or three promises, it becomes very long. The dot then dot catch.
okay,
So if there are two three promises, I use try catch.
okay,
Okay. Any doubt? Async await is pretty simple. You just wait for the promise to get resolved. If it gets resolved, the data is whatever the promise returned. And you, whatever you want to do with the data, you do all the computation later on. Okay. Any doubts? We did asynchronous code using await, using dot then dot catch. I hope this made things clear.
Sir,
yes, sir.
Yeah, go
sir,
ahead.
sir, I have a doubt. Uh, so the first code, like the initial code that you took at the start, you have written so like the error in the between, but the error was printed at the last.
Okay, let me go. First, let's see. Anyone having any problem with the async await part? Okay, let's go to that. The first problem. We were here, right? This one. So you were saying I had an error over here, but I got the final output over here. Is that what you're saying?
No, no, sir. Like here, the catch is at the last, so we are getting it.
Yes.
Not this one.
So if I remove the catch, will that be okay?
Yes, sir.
Okay. So I removed the catch. I am throwing an error over here. So you're saying why still the code continues and I get an error at the end and not and does not the code does not stop over here. This is because we have a dot finally, because dot finally will execute no matter what. If it's an error, it will still execute. That's why unless all the dot finally gets over, it will not show an error. So first it will execute and see I got to whatever I had in dot finally I will execute no matter what, and then only it will show an error, because that's the whole functionality of dot finally. It has to execute, otherwise what will be the use if it stops execution?
Okay, sir. So the error will be at the last, like after the finally is get.
Yes, and dot thens will not get printed, of course. And if there is a dot catch, the dot catch will handle that error.
Yes, sir. Thank you,
Okay,
sir.
does that answer you?
Yes, sir.
Okay, any other doubts? Okay,
Sir, that
so we are done for the
sandwiching.
session. Huh.
Sir, I have a doubt. Sir, that
Yes.
sandwiching of then multiple then and catch using
Hmm.
async functions is complicated, right? It's not that easy
Yes.
as it is in this dot then dot com. Similarly for dot finally also, right?
Huh. Yes. So what were you saying? Like
So what I'm saying is that
it's a
for some conditions we may use this, and for some the other one is not more suitable async await.
no, both can be equivalent. It's just whatever is your preference. See, sometimes when you're chaining these things, it becomes very long and unreadable. But you can same do the same thing with await. So if I'm going here, oh, where did I go? Okay. Yeah. So if I do the same thing over here, I can just have another await over here, constant data 2 equal to await, prompt 2 const data 3 equal to await. You can have it like this. So whatever is your preference, you can do that. This looks more readable when you have a lot of promises you have to await for. Okay. Any other thing? Okay, then we'll close the session.
Thank you, sir.
Okay, thank you.
Thank you so much.